So now we will learn how to represent square root of x on number line for any given positive real number x geometrically, or and we have to find square root of x for any positive real number x. So mark the distance x units from a fixed point A on a given line to obtain a point P such that AB is equal to the x units. Now from B, mark a distance of 1 unit and mark the new point as C. Now find the midpoint of AC and mark that point as O. This is the midpoint of line AC and this will be the point O. Now draw a semicircle with center O. Now let's draw a semicircle So now let's draw a semicircle with center 1 radius OC. So now draw a perpendicular line to AC passing through B and intersecting the semicircle at D. So this is a perpendicular line and intersecting the circle at point D. This will be the point D. So we have to calculate this distance PD, right? So now we can calculate the radius of a circle. So here we will say radius of a circle will be AC time divided by half of the diameter AC. We can say AC is AB plus BC. Right? AB is given x unit plus BC is given 1 unit divided by 2. So this is the radius of circle. So the radius of circle can also be given as like AO, and radius of circle is also OC, and this will also be OD, and that is equal to the x plus 1.2. Now we will calculate the distance OB. So now we will get OB equals to the OC minus BC. So this radius OC minus BC. So what is OC? OC is the radius. So we will calculate OB equal to OC is x plus 1 by 2 minus BC. BC is the 1 unit. So like it will be like x plus 1 minus 2 by 2. It will become like x minus 1 by 2. So this is the distance OB. See, so now we have OB. Now we know OD, that is the radius of the circle, semicircle. So we can calculate this BD. So by using the Pythagoras theorem, we will get BD is equal to the square root of OD square minus of OB square. So that will be equal to the OD. OD is x plus 1y 2 का whole square minus OB. OB is x minus 1y 2 का whole square. So let's open this expansion. We will get square root of x square plus 2x minus 1 minus x square minus 2x plus 1 by 4. So we will get x square plus 2x minus 1 minus x square plus 2x minus 1 by 4. There is a x square is cancel out and this, sorry, this 1 and 1 cancel out. It become 4x, so we can say like 4x by 4. This 4 cancel out. So we can say this BD is equal to the square root of x. Now we have calculated this BD and that will be equal to the square root of. Now we have located that this distance is square root of x and x is given. Now we have located the square root of x. So now how we will locate this x on the number line? So now to know the position of this square root of x on the number line, let us treat the line BC as a number line with B as 0 and C as 1 and so on. So now extend this line. Now we will draw an arc with center B and radius BD, which intersects the number line in E. So let's draw an arc. And this will intersect at point P, number line at point E, and this point will represent the square root of x. As this E point represents the square root of x. In this way, if the number x is given, we can find the square root of x geometrically, and we can also locate this square root of x on the number line. So now let's solve few more examples. Here it is rationalize the denominator of 1 upon 2 plus square root of 3. Here rationalize means an equivalent expression where the denominator is our rational numbers, right? So here we will multiply and divide. One upon 2 plus square root of 3 by 2 minus square root of 3. So we get 1 upon plus square root of 3. We will multiply it by 2 minus square root of 3 and divide by 2 minus square root of 3. So we will get like 2 plus square root of 3 times 2 minus square root of 3. So now we will apply the identity to the denominator. What is that identity? Like a plus square root of b times of a minus square root of b, that is equal to the a square minus b. So here it will become 2 minus square root of 3 divided by a square, that is a is the 2 square minus b is the 3. So here it will become like 2 minus square root of 3 upon 4 minus 3. That is like 2 minus square root of 3. So next is rationalize the denominator of 5 upon square root of 3 minus square root of 5. So here again we will multiply and divide, multiply and divide 5 upon square root of 3 minus square root of 5 by square root of 3 plus square root of 5. So we will get like 5 on square root of 3 minus square root of 5 times of square root of 3 plus square root of 5 divided by square root of 3 plus square root of 5. So it will become like 5 times of square root of 3 plus square root of 5 upon square root of 3 minus square root of 5 multiplied by square root of 3 plus square root of 5. Now we will use the identity square root of a plus square root of b times of square root of a minus square root of b equals to the a minus b. Here equal to the 3 and b equal to the 5. So here we will get 5 times of square root of 3 plus square root of 5 divided by 3 minus 5. So we will get 5 times of square root of 3 plus square root of 5 and divide by minus 2. We can also write it like minus of 5 by 2 times of square root of 3 plus square root of 5. This is its simplest form. So next is 1 upon 7 plus 3 root 2. Again we will multiply by 7 minus 3 square root 2 and divide by the same 7 minus 3 square root of 2. So we will get 1 upon 7 plus 3 square root of 2 times of 7 minus 3 square root of 2 upon 7 minus 3 square root of 2. So we will get 7 minus 3 square root of 2 upon 7 plus 3 square root of 2 times 7 minus 3 square root of 2. So here applying the identity. So what is that identity is like a plus b times a minus b is equal to the a square minus b square. So here we will apply this identity. So we will get a square, that is 7 square, minus b square, that is 3 square root of 2 square. 7 minus 3 square root of 2. We will get 7 minus 3 square root of 2 on 7 square, that is 49, minus 3 square root 2 square, 3 3 3 is 9, 18. So here you will get 7 minus 3 square root of 2 divided by 35. This is its simplest form. Now laws of exponents for real numbers. So we know that for natural numbers, a, n, and n, following laws of exponents hold true. And what are those laws? First one is a to the power n times of a to the power, and it will become a to the power m plus n. Second one is a to the power n to the power n become a to the power m times n. Third one is a to the power m divided by a to the power n. It will become a to the power m minus n, where m is greater than n. Fourth, a to the power m times of a to the power n. It will become 8 times of b to the power n. Now these laws hold true for the natural numbers a, m, and n. So now let's look into the laws for the real numbers. So let's say that a be the real number such that a is greater than 0 and n a positive integer. Then for this real number a, it will be nth root of a is equal to the v if v to the power n is equal to the a and this v is greater than 0. So now that a is greater than 0 be a real number, and p and q be the rational numbers, then following laws hold true. So what are these laws? First one is a to the power p times a to the power q equals to the a to the power p plus q. Second one is a to the power p to the power q equal to the a to the power p times q. Next one is a to the power p on a to the power q, that will equal to the a to the power p minus q. Next one is a to the power p times p to the power p. It will become a